All right, IM2 classes. Today we are solving quadratic equations by using square roots. Just using some algebra to solve square roots. Starting off, we're going to solve this equation. I'm going to rewrite it down here. Did I not change the color on my pen? No. I'm going to rewrite it down here. 3x squared minus 27 is equal to 0. I'm going to draw a little line of separation just to help keep track of the different sides of the equation. So I want to get x by itself. First thing I'm going to do is add 27 to both sides. The 27s here cancel out. So I get 3x squared is equal to 0 plus 27 is 27. Next, I'm going to divide both sides by 3. So multiply by 3, divide by 3 over here cancels out. So I get x squared is equal to 27 divided by 3 is 9. And then from here, what you want to do to eliminate the x squared, get x by itself, you are going to take the square root of both sides. So you're going to get x is equal to 3. But here's the deal. It can be a positive or negative 3 because if it's, so let me back up a minute. So we're going to put plus or minus 3 like this. So we'll have the two solutions, a positive and negative for 3. The reason why it can be positive or negative, so if we get all the way down to this part here, x squared equals 9. If we put in a positive 3 in for x, right, get a positive 3 squared is 9, and that checks out. That's good, right? If we put in a negative 3 for x, negative 3 squared is also a positive 9, so that checks out. So when you take the square root, it's going to have two solutions, positive or negative. Don't forget that at the end. That one's just going to come out to 0. We're going to skip ahead. We can do this one. So line of separation. First step on this one, I'm going to subtract 11 from both sides. You're going to get plus 11 minus 11 cancels out. So you get negative 5x squared is what's left on the left side. 16 minus 11 is 5. Next step, I'm going to divide both sides by negative 5. So these cancel each other out. You get x squared is equal to 5 divided by negative 5 is negative 1. And then I'm going to take the square root of both sides. And then here we have a problem. We can't take the square root of negative numbers. Those are imaginary numbers, all right? Because there's nothing we can square, no real number that we can square to get us a negative 1, right? Because if you think it's, well, square root of positive 1 is 1, but so you're thinking if square root of negative 1 would be negative 1, well, negative 1 times negative 1 would be positive 1. So it doesn't work out. So all we need to say here, if you get down to it and you're taking the square root of a negative, we're going to leave it as no real solution. All right, we'll get into the imaginary numbers later, but for right now, we can leave it as no real solution. Moving on. All right, so these are a little bit different because we need to take the square first. So we have parentheses. So I'm going to take the square root of both sides first. So I'm going to get x minus 1, square and the square root cancel out, is equal to a positive or negative 5. I actually need to get a little bit too much here. So here's the deal with this. Now we're going to have two solutions. There are going to be two different solutions. So I need to take this, and from this point, I'm going to split it up into two different equations to solve. So I'm going to have x minus 1 is equal to a positive 5. And then over here, I have the x minus 1 is equal to a -5. So all I'm doing, let me fix that first. So all I'm doing here is taking the positive, the plus or minus, and I am wrong one. Ha, great. Splitting it up in front. So this, there's nothing there, but that would be the positive, and then this would be the negative, right? So it's this plus or minus getting split up there. And then from here, solve each in equation here. So I'm going to add 1 to both sides here. So I get x is equal to a +6. This one over here, if I add 1 to both sides, I'm going to get x is equal to a -4. -5 plus 1 is -4. So my two solutions on this are at 6 and -4. All right, let's do another example here. So first, since I have stuff outside the parentheses, I kind of need to get rid of that stuff first. So I'm going to divide both sides by 4. So I'm going to have x minus 3 squared is equal to 9 over 4. I'm going to extend this a little bit. Then from here, I can take the square root of both sides. I know we have a fraction. We're just going to deal with it. So deal with this. So on the left side, the square and the square root cancel out. So I just have x minus 3. Over here, I can just take the square root of the top and bottom. We can go back and look at our lesson on radicals here. This can be plus or minus. Square root of 9 is 3, square root of 4 is 2. So plus or minus 3/2. And so again, I need to separate out these into two equations. So it's going to be x minus 3 is equal to a +3/2, and x minus 3 is equal to a -3/2. All right, so from here, solve each individually. I'm going to add 3 to both sides. I'm going to do this math off to the side with the fraction. So I'm going to have 3/2 plus 3. All right, I'm going to make the 3 a fraction by 3 over 1. I need common denominators. Common denominators between these are going to be 2. So I need a 2 on the bottom here. To change that 1 to a 2, I'm going to need to multiply top and bottom of this one by 2. Right? So 1 times 2 is 2. I already have it there. 3 times 2 is 6. Then when I add together, so you just add the numerators, 3 plus 6 is 9. So this one comes out to x is equal to 9/2. Then I need to add 3 on this side. All right, I'm going to do that off to the side again. So it's going to be -3/2. Plus, I already know the common denominator, 3 is going to change into 6 over 2. So I don't need to go through the nonsense again. Common denominator again. -3 plus 6 is +3. So this one comes out to x equals +3/2. Those are my two solutions, 9/2 and 3/2. All right. Yeah, I think we're good. And we'll do this one. So first step I need to do is take the square root of both sides. So there's nothing on the outside, don't need to worry about that. So this one is going to come out to 2x plus 1 is equal to square root of 36 is plus or minus 6. Again, with the plus or minus, we need to separate it out into two equations. So I'm going to get a 2x plus 1 is equal to a +6, and a 2x plus 1 is equal to a -6. And then I just solve each of these individually from here. So from here, it's going to be -1. So I get 2x is equal to, right, I'm going to leave that. 6 minus 1 is 5. And then I'm going to divide both sides by 2. 5 over 2 does not reduce. So I'm left with x is equal to 5 halves. That's good enough there. Next one. Line of separation here. Solve that one. So I'm going to subtract 1 from both sides. So I'm going to get 2x is equal to -6 minus 1 is -7. And then I'm going to divide both sides by 2. -7 over 2 does not reduce to anything. So this one's going to be x equal to -7 halves. We're done with that one. Couple more. So here, this one we need to look at. What do we do if we don't have a perfect square? So first thing I'm going to do is add 13 to both sides. So -13 plus 13 cancels out. So I get 4x squared is equal to 28. And then I'm going to divide by 4. Then I'm going to get x squared is equal to 7. And then I'm going to take the square root of both sides. And so I'm going to get x is equal to, since 7 is a perfect square, we're just going to leave it as a square root of 7. If it's a buddy system thing, if you can simplify it, put it in simplified radical form, we do that. But this one we can't. So we're just going to do plus or minus the square root of 7. Leave it like that. Keep it simple. All right. One more example. What we do when we have fractions come out there. So first step, I'm going to subtract 2 from both sides. Take care of that 2. So I'm going to have 5x squared is equal to 6 minus 2 is 4. Then I'm going to divide by 5. So I'm going to have 5x squared is equal to 4/5. Left, no, I'm not going to have the 5x squared. The times 5 divided by 5 cancels out. So I'm just going to have x squared is equal to 4/5. Almost became a harder problem. Square root both sides. And so for here, I get x is equal to plus or minus. I can take the square root of the top. Square root of 4 is 2. And then square root of 5 is just square root of 5. We do want to rationalize the denominator. Again, check that last lesson. So to rationalize the denominator here, all I need to do is multiply top and bottom by the square root of 5. I'm going to get x equal to plus or minus 2 over, or excuse me, 2 times root 5 is root 5. On top, root 5 times root 5 is just 5. So plus or minus 2 root 5 over 5. And that will do it for this time. All right.